This is Level 2 video lesson number 5. We will be covering Chapter 2, Section 3, and this will be an introduction to deductive reasoning. This will be the different type of reasoning from what we've used before, inductive based on patterns, to deductive, which is going to be based on logic and all the if-then statements that we've been studying. So first, deductive reasoning as a definition. The process of reasoning logically from a given statement to a conclusion. As long as the statements we're working from are true, this deductive reasoning will lead us to a true conclusion. So when we look at our if-then statements, we have to start off with the fact that they are true or intended to be true in order to lead us to a true conclusion. So, if a car battery is dead, then the car won't start. We've been looking at this statement a lot because we know that it's true. Logical conclusions mean that now we can go out and look at a situation like the mechanic who's working on a car and he tests the battery. He finds out the battery is dead. What conclusion can he make? Well, we have successfully come to this hypothesis that the car battery is dead. And because this is a true statement, we can deductively come up with the conclusion that the car won't start. If we are given the hypothesis, we get the conclusion only when the statement is true, the original statement. So this is the beginning steps of logical deductive reasoning. Now, that previous conclusion about the car battery has a name in the logic world we call the law of detachment. The law of detachment tells us that if we have a statement that if A occurs, A is any event like a car battery being dead, then B occurs. So we have a cause and effect. If the car battery is dead, then the car won't start. If this is a true statement, or we intend it to be true, which I'll give an example of in just a second, then if we happen to find out A, we can guarantee that B will happen. So now we're looking at only being given part of the statement and knowing that the rest comes true. Here's an example of one that is intended to be true. If Mr. Jackson tells his son, if you get an A on your math test, then I will take you to the movies. Now, this is not a mathematical fact or anything like that, but I intend this to be true. When my son comes home and he has an A on his math test, given that this was an intended to be true statement, we can make a logical conclusion here. It is not logical to say that he's going to go get yogurt. We don't have anything that suggests that. But we can say that Mr. Jackson is going to take him to the movies because this is a true statement and we were given the condition, get an A on your math test. We get the result. So this is the basic law of detachment, but it really leads to some really interesting situations. For example, how about this? If it is snowing outside, then the temperature is less than or equal to 32 degrees Fahrenheit. Well, this is true. So if it's snowing, the temperature is less than or equal to 32 degrees Fahrenheit. Now, let's go out and find an example here. Mr. Jackson goes out one morning and checks the thermometer and sees that it is 20 degrees Fahrenheit outside. What conclusion can he make? If you just said the conclusion is that it's snowing, well, that's incorrect. The conclusion is nothing. In this case, we were not given the condition. We were not told it's snowing outside to where we can find the conclusion. Rather, we were told the conclusion. This does not produce any result for us. The law of detachment says that if you have a true statement that if A occurs, then B occurs, you have to be given A. In this example, we were given B. No conclusion can be made. here it is in shorthand, and we should learn this. We should really understand this. If A then B is a true statement, so if it's snowing, we know it's less than 32 degrees, then if you are given A, you do get B. So if you look outside, hey, it's snowing. Somebody else can conclude, must be less than 32 degrees. But if you're given B, it's less than 32 degrees. We get nothing. Okay. Is it snowing? I don't know. It could just be a sunny day, less than 32 degrees. If you're given the opposite of A, now this becomes the inverse. Well, the opposite of A, we look outside. Well, it's not snowing. We have no conclusion. We don't know how hot it is, or we don't know that it's below 32 degrees or not below 32 degrees. We just know it's not snowing. But the most interesting one is, what if we're given the opposite of B? Okay, so the opposite of B, I shouldn't have put not B, I should have put the opposite of B, but they're the same thing. So we look outside and we say, well, we check the thermometer, it is not less than 32 degrees outside, it is above 32 degrees. Okay, well then we get the opposite of A, it's not snowing. It can't be snowing, because if it was, it has to be below 32 degrees, and it's not. So, if you're given A, you get B. If you're given the converse, meaning you're given B, you get nothing. If you're given the inverse, the opposite of A, you get nothing. But if you're given the opposite of B, this is the contrapositive. If the original is true, the contrapositive is always true. So if you're given the opposite of B, you get the opposite of A, because the contrapositive and the conditional are always linked. Okay? So that is the most interesting one. Look at this statement. Mr. Jackson's car started this morning. What can you conclude? Go back to the beginning of the lesson. If a car battery is dead, the car won't start. Mr. Jackson's car started. Well, we can conclude the battery must not be dead, because if it was dead, the car wouldn't start. But the car did start. Battery's not dead. This is the contrapositive. If a car battery is dead, the car won't start. Contrapositive. If the car does start, the car battery is not dead. Guaranteed that if you are given the opposite of B, you get A, because it is linked to the contrapositive. Okay. Now, if the original statement was a biconditional, well then every single one of these would get a conclusion. That means that the converse is true, the inverse is true, and we get conclusions no matter what. So watch out for biconditionals where given A, you get B. Given B, you get A. You get everything. The next logical process we're going to look at is called the law of syllogism. In shorthand, this is what it tells us. If A then B is a true statement, and if B then C is a true statement, we can make a logical progression that if A happens, then B happens, and if B happens, then C happens. So if A, then we get C. It's jumping over the middleman. Now, shorthand is very odd without looking at an example. So, here's your example. If it is Tuesday, then Mr. Jackson has volleyball practice. If Mr. Jackson has volleyball practice, then he will work on his jump training. Okay, what conclusion can we draw from this? Well, we can put it together. If it is Tuesday, Mr. Jackson will work on his jump training. Because if it's Tuesday, he has practice, and at practice, he works on jump training. So we're kind of cutting out the middleman. Make sure you understand that if the conclusion of one statement is the hypothesis of the other, then we can take the hypothesis of the first and combine it with the conclusion of the second. That is the law of syllogism. One final example for this lesson would be to look at how could we use both. If my car battery is dead, then my car will not start. If my car will not start, then I will be late to work. Now, we're not going to analyze whether or not these are 100% true. Instead, I am telling you that this is true for me. If my battery is dead, I know my car won't start. And I know that if I walk out to the car and it won't start, I'm going to be late. I'm going to be late to work. Well, guess what? On Monday, Mr. Jackson was not late to work. What conclusion can we make here? Well, I wasn't late, so that's the opposite of B, which means I get the opposite of this A. So the opposite of my car will not start is that my car will start. Okay, now if my car will start, that's the opposite of this B, so I get the opposite of this A. Battery's dead? Well, no, the battery must not be dead. The battery is not dead. Let's go through all the conclusions we can make. First of all, the law of syllogism says, if the car battery is dead, then I will be late to work. Because if it's dead, my car won't start. If my car won't start, then I'm going to be late. Second conclusion, we are given the opposite of the conclusion. Therefore, we get the opposite of the hypothesis. We're given that I was not late. So therefore, car battery must be fine. I was not late, so the car battery is good, because if the car battery was dead, I would have been late. But I wasn't. So there we have it. This is the combination of the law of detachment and the law of syllogism and the unique connection between the conditional and the contrapositive. That's it for video lesson number 5 for level 2. We have one more video for this, and then we will be done.